Continuing on with logistic growth, in number 33 and 34, we have a guppy population in a tank, and it can support no more than 150 guppies. The other one is talking about an animal preserve that can support no more than 250 gorillas. But if we look at number 33 here, we have to come up with this equation. And as I stated in the previous video, I'm going to show you how we can come up with this equation. But for right now, we're just going to use this equation to analyze part B, and we're going to use this equation to analyze part B here. So the first one says find a formula for the guppy population. We're just going to accept this, and I'll give you the derivation later. And then in part B, it says how long will it take for the population to be 100? So what I did is I put both equations in here, and then I'll just use the equation that I need at the correct time. So here's the first equation for the guppy population. And if you notice, I have plenty of parentheses in here. I've got the 150 divided by, and then I have the whole denominator. For 34, I have the 250. I have the whole denominator. Notice that I have double parentheses here, double parentheses here. Now, I changed my window to go out to 100. I wasn't sure what my value of x would be until that graph leveled off. And then, but I know that my maximum is no more than 300 because this one is 150 and this one is 250. So this max of 300 will help me when I graph this because I know that it won't go past 300. So now I'm going to turn on this equation, and I'm going to graph the horizontal line of 100 because I'm looking to see when that population in that tank will be 100. So when I hit graph, you can see how it looks exponential, and then it starts to level off here. And then here comes my horizontal line, and I just need to find that point of intersection. So if I hit second trace, intersect, and then I can get that point. So for the first part, it would be about 17, all right, 0.205. And in this case, we are talking about the amount of time is in weeks. So this is just a little bit over 17 weeks. Now, the next one that we had to do was find out when the population would be 125. So I'm just going to change that to 125. And then when I hit graph, again, here's my logistic curve. Levels off. This is my maximum carrying capacity of 150, and now I'm up at 125. So if I hit second trace and I find that point of intersection, then we see that that turns out to be a little over 21 weeks. So 21.278. And again, those are in weeks. Now 34, they're asking a little bit different question. So I'm going to take off the highlight here, and I'm going to highlight the equation in Y2. And I don't want this to be 125. Okay, I want this to be 250. Now, when I graph this, you can see how it takes off, and then it starts leveling off at 250. Okay, and then now we can see that here's my horizontal line at 250. It's really a horizontal asymptote. The question is, when will it reach 250? Let me just show you what happens here. If I do second trace, 5, and I want to find out that point of intersection. If we wait for it to graph, it's trying to find that point of intersection, but it says there's no sign change. And what's happening is that 250 does not intersect the graph because it's a horizontal asymptote. So I'm going to cheat slightly here, and I'm going to go to that 250, and I'm going to change it to be 249.5. So we're going to change it to just a little bit less than 250. And now when I graph it, I still have that horizontal line, but now I should be able to find a point of intersection. And so now when I do second trace, enter, 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 I will now be able to get a point of intersection, and that turns out to be about 83 years. Okay, so now this is about 83 years, and at 83 years, that's going to be at 249.5. Now, I can change that 249.5 to be 249, 248, 247, and that will change the number of years. You can see how this thing starts leveling out. So once we get past a certain point here, those y values really do not change much at all.